Matthew, how are you?
Fine, sir. My
Fine.
class just ended, so that's why I was a bit late.
Sorry, can you please repeat that? Your
My
voice is
biology class just ended, so that's why I was like
okay.
just 5 minutes late. So yeah.
Not a problem. Okay. So I think the lecture has not been uploaded. I will send you the link once it gets uploaded. Okay. I'm slightly summarizing what we learned in the previous lecture, and then we can move on towards to this lecture. So in the last lecture, that is, Matthew, you were absent yesterday, right?
No, sir, I was there yesterday.
Actually, you were there. Who was absent then? Everyone was there. Yeah, everyone was there. Who was absent? Okay, Andrew was absent.
Yes, sir, with that qualitative analysis, right?
Yeah, yeah, yeah. Correct. Okay, fine. So the last cell that we looked was aqueous NaCl. Let's look at another cell. This is going to be your fourth cell. Please write aqueous CuSO4 with platinum electrode. And we are still using an inert electrode. Now, what are the reactions possible? Like, obviously, we are going to have these ions, copper 2 plus and SO4 2 negative. Then with water, we are going to have H plus and OH negative. Now, if I talk about the possible reactions, number one, at cathode, what we can have, the possible reaction at cathode will be copper 2 plus. Now, since it is cathode, it will get reduced to copper. And we should know that this is a Chapa element, not a wedding element. That is why the reduction potential of copper is going to be positive. If I compare this with water, then from water we'll get H plus ion. It will give, let's take 2H plus ion and 2 electron, giving you H2 gas. Now the SRP of this reaction is going to be 0 volts. So obviously this is not going to happen. This reaction is going to happen. Why? Because SRP of copper 2 plus is greater than that of H plus, right? Now, if I look at the possible reaction at anode, second is at anode, then there are two reactions that you can see here. I can write one for SO4 2 negative, right? I can write one for SO4 2 negative, but since it is very big ion, and generally whenever we write aqueous CuSO4 and these aqueous solutions, these are always in what? Dilute concentrations. Okay, so we'll not, so this particularly big ion, it is going to move very slowly, and that is why it will require some over voltage. Hence, OH negative is going to be oxidized. Rather than writing OH negative, you can write the reaction like this: 2H2O 2H2O giving you O2 gas plus 4H plus and 4 electron. If you see this, why am I writing this like this? So you can say that this 2H2O will give you 4H plus. Sorry, it's going to give you 2H plus 2OH negative, right? Now this 2H plus and this 2H plus can be getting cancelled. Okay, so in that way we can write this reaction like this. Now the products will be, products of electrolysis is going to be, at cathode we are getting what? Copper, right? This is what we are getting, copper solid, and we are getting O2 at the anode. These are the products of the electrolysis. Right, for the fifth one. At first, AgNO3 with PT electrode. Now, here also the same thing is going to happen. As you can see from Ag is also a what? Ag is also a Chapa element, right? We have copper and silver both in the Kappa elements. And that is why it will have a standard reduction potential, which is positive. Hydrogen is going to have 0. That is why the reaction at cathode is going to be Ag plus 1 electron, giving you Ag solid. Why? Because if I compare the SRP of Ag plus, this is greater than the SRP of H plus. Next, at anode, again from NO3 negative, NO3 is negative will be again a bigger element, a bigger molecule, and that is why what is going to happen here? Here we are going to get H2O to O2 gas plus H plus and plus 4 electron. You can balance this by multiplying this by 4 if you want to write the complete cell reaction. But generally, complete cell reaction is not really asked. They will ask me the products of electrolysis. Products of electrolysis will be, you're going to get silver in the cathode, and we are going to get O2 gas in the anode. Okay, now let's move on. Sixth one. We have here aqueous CuCl2. It's again the same thing, CT electrode. Now, here again, copper is going to be getting reduced at cathode. Copper 2 plus 2 electron, giving you copper solid, because the SRP of copper 2 plus is greater than that of H plus. Secondly, what do we have here? Secondly, we have Cl. Now you can see that Cl is what? Cl is slightly smaller than OH negative, because oxygen and hydrogen, these are two different atoms, and here we are having only chlorine. So the reaction here, it is going to be 2 chlorine negatives, giving you Cl2 gas plus 2 electron. What is the reason? Due to over voltage. Due to over voltage. The products are going to be copper in the cathode, chlorine gas in the anode. Right, the seventh reaction, aqueous H2SO4. It's same thing, platinum electrode. Now if I compare H2SO4, this is also going to give you H plus, and from water you are also going to get H plus. So in the terms of cation, we are not having any different cation here. Okay, but the anion is different. So obviously, if I talk about the cathode, then only one reaction is possible. That is the reaction of H plus eating 2 electrons to get converted to hydrogen gas. But if I compare here, the anodic part, so in anode, there are two possible reactions. So when you are having a dilute solution, when you are having a dilute solution, the SO4 2 negative will be very low. And when the SO4 2 negative is going to be very low, the reaction of OH negative will happen. So H2O giving you O2 gas plus 4H plus 4 electrons. Okay, but when it is concentrated, then what happens? SO4 2 negative reacts to make S2O8 2 negative, and it gives out 2 electron. This further reacts with H plus, which is abundantly available in the solution, forming H2S2O8, which is also known as peroxo disulfuric acid. Peroxo disulfuric acid. Okay, so till here is the last case with inert electrode. Now we are going to look at active electrode. What happens when we have active electrode? The eighth one will be, we have aqueous CuSO4 with copper electrode. Now, since we are going to have copper, now the copper rods, these are dipped inside what? These copper rods are dipped inside CuSO4 solution. That means the copper rods are very much available to give the copper ions. It will give you the copper ions like this, Cu2 positive. Okay, and then further what is going to happen? The same Cu2 positive is going to get reduced. So there are two reactions which is going to happen at anode. At anode, what is going to happen? So copper ion, the copper in the rod, it is going to leave 2 electrons and form copper 2 plus. This is same as writing 2 electron in the product side. I've just written it here. And in cathode, we are going to have copper 2 plus 2 electron, giving you copper. Now the important thing to note here is this copper is coming from rod, and this is going to solution, and the same this copper 2 plus from solution is going to rod, and this is going to rod. Okay, so this is coming from the anode, and this copper is getting deposited at the cathode. Now, this type of methodology is also used for the purification of metals. For example, if we are going to have impure copper here, the copper is not pure, it is having some impurities, let us say some different metal, but that metal is not going to go into the solution because the solution is of copper 2 plus. So only copper 2 plus is going to get into the solution, and from here the copper 2 plus is going to get reduced. This is your negatively charged, this is positively charged, right? It is going to get reduced. So from here it is what? Impure copper is coming towards the solution, and it is getting deposited as pure copper. Write this down and see the similar thing happens with aqueous AgNO3. With silver electrodes. And so it will give you Ag plus. This will get converted to Ag. Your positive, this is your negative side. The reaction is very similar to the copper one. You can try on your own also. Otherwise, I will write it down. So what is going to happen at anode? You're going to get Ag minus 1 electron forming Ag plus. At cathode, what is going to happen? We're going to have Ag plus 1 electron, giving you Ag solid. Okay, so this is your again impure to pure. Done everyone, yes or no, please tell me.
Done.
Yes, sir.
Done? Okay. Now, this is all about now. These many cells are obviously not in your syllabus. I have gone a bit far, but it is just that अगर कुछ और आगे पीछे से पूछा CBSE में, then you can answer it very correctly. Okay. So these many cells are not there. Right, next. The quantitative analysis. Qualitative we have already done now. So it is now quantitative analysis of electrolysis. Now, this complete quantitative analysis was given by Faraday, and we have two laws of Faraday that we have to study. So please write Faraday's law of electrolysis. He did not come up with any fancy name, just first law for electrolysis. The first law of electrolysis says that, it's very intuitive also. If you are flowing more electricity, if you are having a battery of high power, then more and more mass will be deposited or more gas will be liberated. Okay, so please write the mass of chemical substance, the mass of chemical substance deposited or liberated at an electrode is directly proportional to the current passed and time, and for how much time you are passing that current. It is proportional to both of these things. That means I can write the mass directly proportional to I. Mass is directly proportional to time. And what else? I can also write mass is directly proportional to I into T. Now I have to put a proportionality constant. So mass is equal to Z times IT. Okay. And what is I? I is equal to the charge upon time, right? So we can write Q is equal to IT. That means the mass is equal to Z into Q. Now this Z is known as electrochemical equivalent. What is Z? Electrochemical equivalent. Okay, the formula for this is, but generally it is not used. It is equivalent mass divided by Faraday's constant. Okay, but essentially what is Z, the equivalent, the electrochemical equivalent? It is the mass deposited when Q will be equal to 1 coulomb. Okay, it is the mass deposited when the charge is equal to 1 coulomb. Please write. Electrochemical equivalent is defined as mass deposited or liberated when 1 coulomb of charge is passed through, when 1 coulomb of charge is passed through electrolyte, any electrolyte. So see, these definitions are also important, okay? Even though this chapter may seem that it is completely numerical, but these definitions are also important. They will ask you these things in 1 marks, okay? So please also think, whenever you have a numerical type of chapter, think what questions can be asked in 1 mark. So these definitions are important. Then you will feel, okay, fine, these definitions are important. Otherwise, people just pass through these and they don't even remember. The electrochemical equivalent jab aata hai exam mein, so they don't know. And like, you cannot put it in a tough question type of thing, right? So it is the most regret you will feel is when you miss an easy question. जब बहुत टफ पेपर आता है तो उतना अफसोस नहीं होगा आपको, but when you are missing an easy question, then you will have much of regret. Okay, so never pass on this definitions without revising. Okay, acha. Now let us move on to the numerical part that is more frequent in this chapter. So if I ask you guys, let us suppose I have one molecule, or rather I should say one ion, that is I negative. Okay, that is I negative. So how much charge will be required to get I2? Let us suppose that I'm having 2 I negative and I want to produce I2 gas. So what do you guys tell me? How much charge is required to neutralize this whole entity? How much charge will be required? Any guesses? Yes, Atif, Aisha, Hamza, Hiba, Krishna, Shaheen, Matthew, tell me. How much charge will be required to neutralize? Achha, fine. ऐसे आप समझिए ना. You have one negative charge. How much charge will be required to neutralize this?
1.
1 what? Positive, negative?
Positive.
Also, so 1 charge is going to be required. Very good. In this case, how much we have? This, if you want to fake, don't worry about this iodine. This is just charge right now. It is what? 2 negative charge, correct? Yes or no?
Yes.
That means we have to neutralize by giving 2 positive charge. Is that right, guys? Yes or no? Please tell me.
Yes, sir.
Is that right, guys? Okay, fine. Now, let us suppose if I want to have, let us suppose if I have 100 I negative. So if I have 100 I negative, I will make half of it. That means 50 I2 will be made. What do you guys think? How much charge is required now? How much charge is required now?
100 positive charge.
100 charges, right? 100 positive charge. Okay. Now again, now we can say that 100 positive charge or electron in the reverse direction. Same thing, yes or no?
Yes, sir.
Like when we have electricity, only electron moves, right? So we have to move 100 electrons, but in the reverse direction. That we have to understand. Okay, fine. If I have this much, then we need 100. What if I have, let us suppose, 1 mole of I negative, and it is going to give me half mole of I2. Now this will require how much charge? This is going to require how much charge?
1 mole of positive charge.
1 mole of positive charge. But again, if in terms of electron, how much electron we have to pass? Tell me. We have to pass 1 mole of electron, yes or no? Correct, guys?
Yes, sir.
Right. And 1 mole of electron is equal to what? 1 mole of electron is equal to what is the charge? 1 Faraday. 96500 coulomb. यहाँ तक समझ में आया सबको? Yes or no? Please tell me, guys. All of you understood this here? Till here, all of you understood this? This
Yes,
whole
sir.
thing?
Yes.
Now let us suppose you have a question like this. Please write the question, okay? Write the question. Calculate the charge. Calculate the charge required in Faradays, okay? In Faraday for following. The first thing that you have to do is, what if I have to make 2 moles of I2 from Ki? Okay, so first of all, how to approach this question? Whenever you get question like this, in which you have been given a compound, you ignore whatever is there. Okay, the spectator ion, that means the one which is not doing any reaction. We have to make I2. So from Ki, what do I need? I need potassium or the iodine? What do I need from Ki? Tell me, guys.
Iodine.
What do I need? Iodine we need, right? And iodine will be present in which form? You have to know its oxidation state. We know that here K plus and I negative will be present. So I will take I negative. And it is going to give me I2. Okay. How many moles of I2? Tell me.
2 moles.
2 moles of I2. That means how much ion do we need? How much iodine negative ions we need? Tell me, guys.
4.
4, right? If I have 4 moles of iodine negative, what is the charge required?
4 electrons.
4 mole, right?
Yes, sir.
4 mole of electron. That means 4 Faraday. Yes or no, guys? Please tell me. Easy?
Yes.
Yes? Okay. For example, if you have been given 2 moles of Cl2 from CaCl2. And here also you don't have to worry so much. You ignore this fact that there are 2 chlorines in CaCl2. Your 2 chlorines will be available in the form of Cl negative only. In दोनों 2 chlorine के बीच में ऐसे bond नहीं रहेगा. So you don't have to worry when you are having ionic molecules. So here also what you are going to do? Here also same thing. Cl negative is going to give me Cl2. And I need 2 moles of Cl2. So I need 4 moles of chlorine negative. That means the charge required is equal to 4 mole of electron, which will be equal to 4 Faraday. Okay. Now write the next one. If you need 1 mole of Al3 plus, I have to convert 1 mole of Al3 plus to aluminium solid. So whenever you have this statement will correspond to a reaction. What is the reaction? Al3 plus to aluminium. How much electron do we need? Tell me, guys. How many electrons do we need?
3.
1 mole.
1 mole of electrons, right? So charge will be equal to 1 Faraday. But please remember that if this was 2 mole of Al3 plus, then you would have written 2 here. Okay? Oh, wait a second. 1 mole nahi hoga na yahan to. Sorry. It will be 3 electrons, na? 3 moles. 3 positive charge hai. Krishna? अभी बैठ के कृष्णा को हम बोला सही जवाब देंगे. Got it, guys? 3 electron, na? Yes or no? Tell me.
Yes, sir. 3.
Yeah. Okay. Fine. So this will be 3 Faraday. कृष्णा समझ में आया?
Yes, sir.
Yes. Okay. Fine. Two mole of copper 2 positive to copper. How much Faraday of charge will be required?
One.
Send the answer in chat. One. नहीं 1 नहीं होगा. फिर से देखिए. Write the reaction. नहीं. Write the reaction. Write the reaction and send me on WhatsApp. ऐसे नहीं होगा आपको मुझे लगता है. Write the reaction. Send me over WhatsApp. I think that's right, Hamza. Write the reaction, guys. You will come to know. Okay, Krishna and Shine, see. Yeah, now it is correct. हाँ, Shaheen, very good. Reaction लिख के समझ में आया ना आप लोगों को? Yes or no, please tell me. Yes, Shaheen, Krishna.
Yes, sir.
Okay. Okay, I have not received answer from few guys. Matthew, I have not got answer from you. Okay, somebody sent me something. Heba, that is correct. Atif, I have not got answer from you, and Aisha, I have not got answer from you. Yes, Matthew, what happened? Atif, what happened?
Just a second, sir. Just a second. I'm just.
Just a second. Okay. Others, you can try this one. For example, if you have been given 54 grams of aluminium to Al2O3. Okay. So in this case, what is happening? You first of all think about the reaction. First of all, you have to again think about the reaction. So the reaction that you can see is, yeah, Matthew, that is correct. Yes, Matthew, correct. The reaction that you can see is aluminium getting converted to Al2O3. Okay, how much of aluminium? 54 grams of aluminium. In terms of moles, that will be equal to how much? So number of moles of aluminium will be equal to the given mass by molar mass. Given mass is 54 grams. The molar mass is going to be 27, which will give you 2 moles. That means I have 2 mole of aluminium. I have to convert it to Al2O3. Don't worry about the oxygen. The oxygen is getting from somewhere else. Okay, you have to get the oxygen from somewhere else. Now, the real question is, this aluminium here, it is having what oxidation state? Here it is 0. This aluminium here, if I look, 2x plus 3 into minus 2, because there are 2 aluminium, that is why 2x, 3 because there is 3 oxygen, minus 2 because the oxidation state of oxygen is going to be minus 2. Okay, this is equal to what? Since this whole molecule is neutral, this is having 0 charge. That means 2x is equal to plus 6, x is equal to plus 3. And aluminium, it generally has the oxidation state of plus 3. Now, what you have to see how much electron is going to be used, you just look at the delta OS. The delta OS is equal to how much? Delta OS is equal to plus 3 and multiply it by the stoichiometry into 2. This will be giving you 6 electrons. Write this down. 6 electrons, that means you'll have 6 Faraday. Charge will be 6 Faraday. Please remember this 2 Al is coming from 54 grams, not here. Okay, this Al has nothing to do with the Al in the reactant. All right, next question, and then we will answer this. I will answer this. Send the answer on WhatsApp for this one. $20 grams of calcium. From calcium chloride. Okay. So here it is just the opposite. You have to calculate the oxidation state. ये आपका reactant यहाँ पे. Okay, this is your product. You have to go from CaCl2 to calcium. How much of calcium? What is the number of moles? You will calculate from here. Okay. Calculate from here. Try कीजिए हो जाएगा. What happened, guys? No answer till now. Acha. Krishna got your answer. आप मोलर मास गलत है कृष्णा. Molar mass is not right. Yes, Krishna, now it is correct. Oh, no answer from anyone else. See, guys, what is the oxidation state? Can somebody send me? Those who have not sent the answer, did you get the oxidation state of calcium here? Send the answer if you have got the oxidation state of calcium. Oh, no one. See, calcium is X plus there are two chlorines and -1 for each, which is going to give you 0 because it is neutral. X is going to be +2. So we have added here calcium 2 plus, which is getting converted to calcium. But how much of calcium do we need? So number of moles will be equal to 20 grams divided by the molar mass of calcium, which is 40 grams per mole, giving you 0.5 mole. So this will be 0.5. Okay, this will be 0.5. Now the number of electron that is used is equal to 2 into 0.5, right? One, this is going to require how much? The delta OS is equal to 2. And how many moles we need? We need 0.5 moles. So delta OS into the number of moles that we need. This will be equal to how much? This will be equal to 1 Faraday. This was just easy. Happy guys. काम कीजिए यहाँ पे इसको 2 कर दीजिए तो Now look here, guys. Mn is again going to be x plus 4 into minus 2. Minus 2 is for the oxidation state of oxygen. There are 4 oxygen, that is why multiplied by 4. This whole MnO4 negative is having a negative charge. That means minus 1. X will be, this will be x minus 8 is equal to minus 1. Hence, x will be equal to 8 minus 1. That means x is equal to plus 7. Now, what we are doing? We are going from MnO4 negative to Mn2 positive, right? That means we are having an oxidation state of plus 7, and from plus 7 we are moving to plus 2. The change in oxidation state is equal to how much? Of 5. And how many moles do we need? We need 2 moles, right? We need 2 moles. So the number of electron is going to be, that means, sorry, the charge is going to be the delta OS multiplied by the stoichiometry, which is equal to what? 5 into 2, which is equal to 10 Faraday. The yaad ho aap logo ko, number of electrons we used to get like this only. And since here we have to get the exact number, absolute number, that is why we are multiplying with the stoichiometry and the delta OS. This will give you 2 Mn plus, but that is not our case. That is not our issue. You have to get this answer right. Similarly, write another one. Similarly, write another one. Let's suppose we have 3 mole of FeO to Fe2O3. So we are going from FeO to Fe2O3. There is 3, so I can just do what? So we need oxidation state. So for iron, it is going to be what? Plus 2 here, because oxygen is minus 2. And plus 2 and minus 2 are going to be neutral. That is why plus 2 here. And let us see for this one. 2x plus 3 into minus 2 is going to be equal to 0. Now 2x minus 6 is going to be equal to 0. And similarly, 2x is going to be 6. X is going to be plus 3. So here Fe2O3, the iron is in the oxidation state of plus 3. Moving from plus 2 to plus 3, the delta OS is equal to 1. And how many moles do we need? 3 moles. So Q will be equal to 1 electron per mole into 3 moles, because we have 3. That means we are going to need 3 Faradays of charge. Let me know when you're done, guys. Okay. Once you're done, you'll write this question. A solution of CuSO4 is electrolyzed for 10 minutes with 1.5 amperes of current. 1.5 amperes of current. Calculate the mass of copper deposited. Now we're going to do this question. First of all, in order to get the mass of copper deposited, whatever mass we are getting, the reaction, what is the reaction happening here? We have CuSO4. From CuSO4, we'll be having Cu2 positive. It will be getting converted to copper. So this is the reaction that we are having. In this reaction, we can calculate the mass of copper deposited if we know how much charge is being passed, right? The important thing here is charge. First of all, we'll calculate the charge. So Q is equal to, in terms of current and time, it is equal to I times T. Q is equal to IT. What is the current here? The current is equal to 1.5 amperes. Into time in seconds, it is equal to what? In seconds, it is equal to 600 seconds. Now, 1 ampere second is equal to 1 ampere second is equal to 1 coulomb. And this is going to give you what, 900? Yeah, 900 coulomb of charge. It's going to give you 900 coulomb of charge. If we talk in terms of Faraday, we can say that this is equal to 900 divided by 96500. This will be Faraday, right? As Faraday is equal to 96500 coulombs. ठीक है? Originally देखिए ऐसे था. Faraday लाए हम, that means what I'm bringing 96500. यहाँ पे coulomb था, right? This coulomb and coulomb get cancelled and you will get Faraday. 96500. So this is the charge that we are having. This is the charge that we are having. Okay. Now, let us look at the reaction. Copper 2 plus getting converted to copper solvent. Now, I can say that this is requiring 2 electrons. That means 2 moles of electrons. So I will say that 2 mole of electron gives 1 mole of copper. That means I can say 2 Faraday gives 1 mole of copper. Similarly, I can say 1 Faraday gives half mole of copper. And this much Faraday, 900, okay, we can write it like this one. Or simplify kar lete hain isko. This 20 will be cancelled. So we'll have 9 upon 965. Faraday gives 9 upon 965 into half mole of copper. Okay. Then you can write in this in terms of mass also. This will be equal to 9 upon 965 into half into what is the molar mass of copper? 63.5 grams of copper. It's very much like the first chapter of 11th standard. Okay. Unitary method is used very much in these type of questions. Please write this down. Is everyone done? Yes, sir. Please tell me.
No, sir.
Write the second law of electrolysis.
Second, sir, can you scroll up?
Yeah, sure. Can I move on now, Matthew?
Yes, sir. Yeah.
Write the second law. How are we writing the laws? Blue. Can all of you see the screen?
Yes,
Yes,
sir.
sir.
Can you see me writing also?
Yes, sir.
Okay, fine. Second law of electrolysis. Please write. When same charge, charge का मतलब क्या? When same charge, that means same amount of electricity with for the same amount of time is passing through different electrolytes. Then the mass deposited is proportional to the mass deposited at electrode, at electrode is directly proportional to equivalent weight. Okay, write a question. You'll understand this law from this question only. Please write. See electrolytic cell. A, B, and C containing ZnSO4, CuSO4, and AgNO3 connected in series. Right, the current of 1.5 amperes, the current of 1.5 amperes is passed through the solution until 1.5 grams of Ag is deposited at electrode. Ag is deposited at electrode. Okay. Now, at this point of time, we are not focusing on the other cells. We are just focusing on Ag because we have been given information about Ag. And this is the current that is flowing. This is the mass of Ag that we have got. Okay. And the first question that they are asking is A, for how long? How long did the current flow? Okay. How long did the current flow? That means if you remember the equation Q is equal to IT, then from here you have been given I. They are asking you the time. That means you have to calculate the Q, and Q is equal to what? If you remember, Q is equal to the delta OS into the number of moles that is being required, right? And this number of moles can be calculated from the mass deposited how much mass we are going to deposit. For example, if you remember the previous questions, in this we saw that 20 gram of calcium, right? In this 20 gram of calcium, this 20 gram of calcium was related to 0.5 moles, right? So right now also you have this 20 grams, you need to get the 0.5, how many moles are being deposited. Okay, so moving on to this question, first of all, what we are going to calculate, the number of moles in 1.5 grams of Ag. So this will be equal to 1.5 grams upon 108 grams per mole. Okay, this is the molar mass of silver. So you can just cancel the grams and grams, you will get 1.5 upon 108. Okay, moles. Now this many moles we have, That means the reaction equation will be something like this. Ag plus, it is going to react. There are some electrons which are being used and it is forming 1.5 upon 108 moles of Ag, right? So since it is going to require only one electron for one Ag, for this many electrons, it will require the same amount of electrons also. That means I can write Q is equal to 1.5 upon 108 Faraday. अगर आपके पास Ag plus से आपको 2 Ag बनाना रहता, that means you would require how much electrons? 2 electrons, right? Because you need to have 2 Ag, 2 moles of Ag. Here I have 1.5 upon 108. That is why I am going to require how much? 1.5 into 108. This is the Q. Now you have got the Q. You just need to calculate the time. So Q is equal to IT. Time is equal to Q upon I. Q is equal to 1.5 upon Q आपका क्या हो जाएगा? हाँ, Faraday का आप लिख लीजिए 96500 divided by what is the current? Current is equal to how much? Wait a second. Q is equal to 1.108 होगा यहाँ पे into 1.5, right? So you can get this as 96500 divided by 108 seconds. So this is the time for which the cell was working or the current was flowing. Write this down. Please like ask me if you don't understand anything in this particular step, okay? I think the reason why we are calculating number of moles is also very much clear from the previous questions that we did. That from the number of from the mass given, I will calculate the number of moles, and I can get the delta OS from what? I can get the delta OS from the equations. Here delta OS is equal to 1, and Q will be equal to what? Delta OS into N. So delta OS was 1. Number of moles was 1.5 upon 108. That is what I have written here. That's it. Okay. That is your Q, and Q is equal to IT. And if you plug in the Q and I, you will get the seconds. I think this will be somewhere around 890 seconds. Hona chahiye. It will be very near to 900 because 8, that will be kind of very close to 900.
$893.5 seconds.
893.5. Okay. This was the first question. The next question that they are asking is, what will be the amount of zinc and what will be the amount of copper, right? Yeah, zinc and copper that will be deposited. See, you have to revolve around only these two equations. Q is equal to IT. Oops, why do I write I and I like that? Q is equal to IT and Q is equal to delta OS into the number of moles. These are the two equations in which you have to revolve the complete thing. Delta OS के लिए आपको क्या आना चाहिए था? Chemical reaction. Okay, you need to know what is the oxidation state starting से लेके end तक from the product and the reactant, the product in the reaction and the product. Okay, fine. Let's move on to the B part of this question. Write the B part. What mass of zinc and copper is deposited? Okay, now if I talk about this question, then you can say that let's talk about zinc first. So zinc 2 plus 2 electron is going to give you zinc, right? In terms of Faraday, if I will say, I can say that 2 Faraday gives 1 mole of zinc, gives 1 mole of zinc, right? Of 1 mole of zinc. That means 1 Faraday gives 1/2 mole of zinc. How much Faraday of charge is passing through? This many Faradays, 1.5 upon 108. So 1.5 upon 108 Faraday gives 1.5 upon 108 into 1/2. देखिए 1 Faraday से इतना मिलता था, 1.5 से इतना मिल जाएगा, 1.2 mole of zinc, right? If you are having $1, you get half kg. So if you have 1.5 upon 108, then you will get 1.5 into 108 upon 2, है ना? So it's that. Now, if you want to convert this to what? If you want to convert this to mass, then you can just multiply by the what is mole. Mole को mass में लिखेंगे तो molar mass हो जाएगा. So you'll have 1.5 into what is the molar mass of zinc? 65.3 divided by 108 into 2. Where is this 2? Sorry. This is 2. This will be in grams of zinc. Okay. Now, each and everything in this particular case will be same for copper also, right? If you give the reaction of copper 2 plus 2 electron giving you copper. So copper and zinc, they will be making same amount, same number of moles, but the masses will be different because the molar mass of copper and zinc are different. Okay, so if I talk about the moles of copper that we are going to get, it is going to be equal to 1.5 upon 108 into half mole of copper. But if I talk about in terms of grams, then this will be equal to 1.5 into the molar mass of copper is how much? इसका उल्टा होता है 63.5 divided by 108 into 2. Okay, because all of these statements will be same for copper and zinc. क्योंकि दोनों कितने इलेक्ट्रॉन यूज कर रहे हैं? 2 मोल इलेक्ट्रॉन यूज कर रहे हैं. ठीक है. Also one more thing, it is अभी आप लोग को ना ये याद हो जाना चाहिए. कॉपर और जिंक का तो याद कर लीजिए. कॉपर और जिंक बहुत ही like it is 29, this is 30, and the molar mass for copper is what? 63.5 और जिंक का होता है 65.3 grams per mole. Okay.
So they will not give it in the question.
अरे पता नहीं ना, नहीं दिया तो क्या बोलिएगा आप, क्या कर सकते हैं. ठीक है, चांस लेके नहीं चलिए तो अच्छा है. ऐसा नहीं मतलब दिमाग में आप पूरा दिन रात कॉपर का नहीं आता है मुझे, आप एकदम उदास हो जाइए, कॉपर जिंक का इनको नहीं आता. उतना भी ये नहीं केस है, इतना भी डेस्परेट मत होइए मोलर मास के लिए. बट स्टिल याद रखिएगा कि एक बार रिवाइज करके चले जाए तो अच्छा है. ठीक है ना. कोई पागल आदमी सीबीएसई का पेपर बनाने लगा तो फिर वो देगा नहीं कुछ भी, है ना मास देगा आपको, ना इलेक्ट्रोड पोटेंशियल देगा आपको. ठीक है. एंड लाइक वेयर डू यू हैव योर बोर्ड्स, इन योर ओन स्कूल और सम डिफरेंट स्कूल?
Own school, sir.
अच्छा, ओन स्कूल में तो फिर थोड़ा मतलब कुछ हो सकता है, जैसे कि मतलब इफ देयर इज लाइक क्या बोले हम, एकदम मिरिंडा पी के अगर किसी ने पेपर बनाया तो फिर आपके स्कूल वाले थोड़ा हेल्प कर सकते हैं.